Alright, let's find the solution to this first order nonlinear differential equation. So the first thing I'm going to do here is to separate variables. So I will write this as dy over dx equals xy to the power half. I just write that as square root of x times y times the natural log of x. Then I'll write this as dy divided by dx equals, I can split up this square root, so I have square root of x times square root of y times the natural log of x. And now you can see that I can separate variables much easier here. So dy divided by the square root of y equals, equals the square root of x times natural log of x dx. So let's take integrals on both sides. So the integral of 1 over square root of y dy equals the integral of square root of x times the natural log, the natural log of x dx. Now of course the integral of 1 over root y is an easier one. Just show you here. So this is 2 root y. Just put this beta inside, 2 root y, okay. But the integral of root x times natural log of x dx is a little bit complex, not so complex, but we can do this by using the method of integrating by parts. So I'll give this special attention. Let me just get a new page here. Alright, so we have the integral of square root of x times natural log of x dx. So I just write this x log of x. Okay, there we go. And this is how the method of integrating by parts works. So if I have, just get a good color here. So if I have a function like u times dv dx, of course with respect to x, then its integral becomes u times v minus the integral of v times du over dx, okay, with respect to x. So let me do this. I'm going to match these letters to the functions here. I better let u to be natural log of x because it is easier to find the derivative of this. I want to find u dx. It is easier to do that if I let u to be natural log of x. So if I let u to be root x and dv dx to be this, that will be much more complex because in order for me to find the integral of natural log of x, I need to use the same method, which is kind of complicated. So let me do this. All right. Now I have, of course, so we've just said let u equal to the log of x. That means the derivative of u with respect to x is going to be 1 over x, all right? And then by virtue of this, we also know that dv dx, dv, just make this better, dv over dx is the square root of x. If I can just separate variables here, dv equals square root of x dx, and then I could just have dv equals square root of x dx. If I take integrals on both sides, all right, what do we have here? We have v, and then this is actually the integral of this is, let's see, x to the power 3 over 2, and this is 2 over 3 plus a constant. I don't really care about that for now. So I have this, just show you here. Okay, so I have the value of v, I have the value of dv dx, I have the value of du dx, and I have u. So I can now put everything together in this formula. Right, so everything here, so I have the integral of the square root of x times the natural log of x dx. This is going to be u times v. What's that going to be? U is natural log of x, v is this, so just write this as 2/3 x to the power 3 over 2, all right, times, okay, natural log of x minus the integral of v, which is this, that's 2/3 x to the power 3 over 2, right, times what's that, du dx, which is 1 over x, all this with respect to x. All right, so we have 2/3 x to the power 3 over 2 times the natural log of x minus 2/3, the integral. Now if I have x to the power 3 over 2 divided by x, or times 1 over x, that's going to be x to the power, what's that? That's x to the power half, right, dx. Okay, so that's 2/3 x to the power 3 over 2 natural log of x minus 2/3. So the integral of x to the power half is actually 2/3 x to the power 3 over 2, like we've just done previously, 3 over 2, plus a constant if you like. So let me add c there. I could just write this as 2/3. For this I can write the square root of x cubed, that's the same meaning, minus what's that going to be? That's 4 over 9, right? So that's 4 over 9 x to the power 3 over 2, which I could also write that way, plus c. Or I can even factorize out this 2/3 times the square root of x, not good enough, okay, x to the power 3, then this, oops, I just need to write this natural log of x here, I forgot that. Okay, so I have natural log of x here minus 2 over 3 plus a constant. So I'm going to carry all this and put it on the previous page, which okay, so here we go. Oops, I can't remember what that was. Okay, that was just get this color. So we have 2/3 the square root of x cubed, then in brackets we have the natural log of x minus 2 over 3 plus a constant. All right, so there we go. Yep. Okay, this 2 here, I don't like it, so I can divide throughout by 2. So I have the square root of y equals 2 over, that's not 2 over 3 now, that's 1 over 3, the square root of x to power 3 times the log of x minus, that's 2 over 3, yes, plus the constant c. Okay, I divided by 2, but of course this is also a constant, so I can let this to be another constant, maybe a, right? So I have the square root of y equals the square root of x cubed divided by 3 times the natural log of x minus 2 over 3, oops, okay, plus a. Let me just square both sides and end with that. So I have y equals, so what happens if I square both sides? This becomes x cubed divided by 9 natural log of x minus 2 over 3 squared plus right, no, I can't do this, I can't do this, sorry about that. Let me just get a rubber here, because I cannot square, there is a plus here, so I've got to put a square on the whole function. So that's square root of x cubed divided by 3 times the natural log of x minus 2 over 3 plus a. All right, so I've got to square all this, squared. All right, so that's my final solution. Thanks for watching this video, and I'll see you in the next one.